In this video, we will learn about the basic idea behind ROS services. So far, we used ROS topics to communicate information between nodes. As the ROS wiki aptly describes, ROS topics are many-to-many one-way communication infrastructures. They are similar to those hundreds of email newsletters that we knowingly or unknowingly subscribe to, but process only a very selected few. Basically, there is no application level acknowledgement involved when exchanging information via topics. Such a communication is useful in the contexts we saw earlier, like a sensor constantly publishing information, monitoring a certain situation. As in, there are no serious consequences if one message was not received because this message is mostly repeated many times. But such an implementation may not always be efficient, particularly if it is important to receive acknowledgement that a certain message was received. Also, the topic-based approach might simply consume too much data bandwidth. Imagine a robotic system manipulating objects in a static scene. It is not wise to constantly publish camera data on a topic, even at a low frequency. It is like watching a movie which has only one picture. In such a case, a snapshot of the scene would be more than sufficient just before you want to manipulate the scene. This is exactly where ROS services can be used. They provide a request-response communication, and a ROS service is defined by using two ROS message types: a request message type and a response message type. For example, in the static manipulation scene analogy, the request message type would consist of a command to the camera to trigger a snapshot of the scene, and the response message will be one image of the scene. In a broader sense, ROS services are the gateway to event-based execution in ROS applications. Now, let's see where we can define ROS services within the ROS file system. ROS services are also defined in the ROS package, where project-specific ROS message types are defined. After all, services are also defined by messages, just that there are two message types that define a service. Although the services are defined in the SRV folder in the messages package, so that they are organized separately from the regular ROS message types. Let's now look at a couple of utility commands. The command ROS service list can be used to list all available ROS services in a running ROS application. And a ROS service can be called using the command ROS service call, service name, arguments corresponding to the service request field. The result of executing the service call will be populated in the response field. We will see these commands and some more in the code illustration that will follow in the next video. Before we do so, let's take a look at an example ROS service definition. In the previous videos, we worked with a simulated sensor that was publishing distance information in the SI units of meters. But in some parts of the world, people do not use SI units and use imperial units instead. So, we are required to create a ROS service that converts SI units to imperial units. Hence, our request message contains a measurement in SI units of meters, and our response message type should contain the same measurement but in imperial units of feet, including a Boolean flag to indicate the conversion was a success if a valid number was provided in the request message for conversion. The service definition is written in the ROS service file convertmeters-to-feet.srv. We first define the request message field. Then we add a demarcation to indicate the end of the request message type. And then we add the response message type as desired. Note that the convention to indicate the demarcation between the request and the response message types is 3 dashes together. Lastly, the processing of the data in the request message of a ROS service is done in the service callback function. We will look at this service callback function also in further detail in the code illustration. Now, Let's take a quick look at the code nomenclature when using ROS services in ROS applications. A service server ROS node advertises a service. As a result, this service is now available for all other ROS nodes. Similarly, a service client ROS node calls a service. That is, a service client can send a request message to the service server once the service is available, and the outcome of the service execution will be populated to the response message by the service server. Before we start coding, a few points to be aware of regarding ROS services. ROS services block the program flow, meaning the program will not continue further until the call for a given ROS service has been completed. Therefore, ROS services are useful for designing sequential behaviors. That is, a desired functionality is implemented as a series of service calls. Due to the blocking nature of a service call, it is desirable to have quickly executing and deterministic computations inside service callback functions. And lastly, there is no going back once we have entered into a service execution until it is complete. All right, let's write some ROS service code. See you soon.